Yeah, so be on your best behavior. Watch the language so I can monetize this later. So I can quit teaching and play Hearthstone full time.
No.
So I think this would be good for everybody to do. Just redraw the two separate triangles. It's a good strategy when doing a double triangle problem. 3U students, you guys will be doing a 3D problem involving three triangles in a moment. But it just kind of lays things out. So obviously we're looking for the height FC, but you don't have enough information in that triangle to find that. Maybe you can find this common side from ecstasy using some trig tool. So it's a right angle triangle, so you have lots of options. So yeah, it's all right angles, so we can't just use SOHCAHTOA for each stage. If you like sine law though, I'm just gonna go a bit crazy here. If you really like sine law, you could use sine law to do this question. This angle would be, did I do that mental math right? 180 minus 90 minus 52 is 38. And then look, you have a side angle pair. So yeah, if you like the sine law, I'll call this side y. Yeah. 61? Because the diagram says they're both 90. Because it says so in the diagram. But it's a 3D diagram on a 2D piece of paper, right? So like, can you guys look at this piece of paper? Do the angles look like right angles to you from where you're at? No, because it's a 2D piece of paper in a 3D environment, but they're right angles, right? Any degrees? $61 plus 90 would have to equal 180. Why? So this is a cliff, and this point X is like across from the cliff. The cliff. So you guys understand this is 90 degrees, and then you look up at the cliff. The angle of elevation is 61 degrees. Okay, and then you walk farther downstream, let's say 75 meters, that forms another right angle. Now, is your issue that this angle looks acute, but it's saying it's 90 degrees? That's because this is a drawing of 3D real life on a 2D piece of paper. Yeah. Anyway, yeah, let's finish solving this one. I'm going to use sine law, and we should get the same answer as you people using SOHCAHTOA. So y over sine 52 equals 75 over sine 38. You can definitely use SOHCAHTOA, as I mentioned, but some people really like the sine law and should get the same answer either way. Sine 52 divided by sine 38. Well, I got pretty much 96 meters. Did you guys get that too? All right, 96 meters. So whether you use SOHCAHTOA or not. And now that same side we just found, 96 meters. We can now, I'll use SOHCAHTOA for this one. It looks like we'll be using the tangent ratio. So we've got tan 61 is opposite. We've labeled that h over adjacent, which we found was 96. Multiply it up. So it looks like it should be a little bit more than 96, maybe around like 100 or something. No, probably more than that. 96, tan 61. Oh, a lot more than 100. 173-ish? All right. 173, I'll call it 0.2. And this is meters. And I'll just say that. That's the cliff height. So I think this problem is reasonable for both classes. It's just a double triangle problem. But I guess the challenging thing would be kind of taking a three-dimensional problem like this one, finding the height of a cliff, and drawing a diagram on a 2D piece of paper. Anything else? You guys want to chat more about this one? You can chat some more if you'd like. All right, well, let's get sorted here. The 3M people, you guys can get going on a problem-solving assignment. There might be a 3D problem in there for you guys. And the 3U people, we're going to do a couple more of these. So I'll pause the recording. All right, we're back. 3U people. Here is kind of the level of problem that is a 3U, guys listen up, a 3U level of problem where we're going to solve a 3D trig problem, this one involving three triangles. So it is a 3D scenario. Sam's house, Elena's house, and this point where the right angle are, they're all on the ground. And this antenna is sticking up out of the ground. It's a 3D problem on a 2D piece of paper. So you guys see this triangle here with the 12-degree angle? This would form a right angle right up in here. I'm going to label this one and zoom in a little bit. And same with this triangle, from Sam's house to the top of the antenna to the bottom of the antenna. On the 2D piece of paper, it does not look like a right angle triangle, but in real life it would be. If Sam from her house looked up to the top of the antenna and then looked at the bottom, it would form a right angle triangle. So on my diagram here, I'm going to zoom in and just add, zoom in, enhance, 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 enhance. I'm sorry, I'm just having fun. I'm going to add a little right angle. That's a right angle triangle. And this is a right angle triangle too. This problem is composed of three right angle triangles. Our goal in this question is to find the height of the antenna. So what I would suggest for you guys, dehance, 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 I would suggest redrawing all three of those right angle triangles and labeling what we know. I'm going to do that down here. Now, maybe we can all decide on some common letters to use for the angles. Are you guys okay with S for Sam's house, E for Elena's house, A for the top of the antenna? What do you guys think about the base of the antenna? Maybe a B? You guys okay with B? Sorry, we got three triangles to draw here. So my first one, I'm going to zoom in a little bit more. I'm going to draw the antenna from Sam's house. So here, so base of the antenna, top of the antenna, Sam's house forms a right angle triangle. Maybe I'll draw the one from Elena's house. Antenna, Elena's house, right angle triangle, the antenna. And if you want to, you could, what's an antenna look like? I don't know. Like this, like Eiffel Tower antenna. How about that? Look at that. And then we have the right angle triangle formed between Elena's house, Sam's house, and the base of the tower. I'm going to draw it like this. Base, Elena. All right, now let's add in what we know. I think everything given in the problem is labeled on the diagram. So Sam to Elena's house is 1,200 meters. So that would be this guy in this diagram. Elena's house is 50 degrees east of north at the S here, so 50 degrees. And then what else do we know? The angle of elevation from Elena's house, the antenna, is 12 degrees. All right, and we're back. So the angle of elevation from Elena's house up to the antenna, 12 degrees. Our ultimate goal here is to get the height of the antenna. I'm going to wait a sec while you guys think about, hey, what do I know in this problem? Is this a two-step problem, a three-step problem? Can you guys think of a strategy that's going to help you find the height of the antenna? So I'll wait a moment while you guys think on that. So goal, height of the antenna. For you guys at home, I will pause the video, let you have a think, come up with a strategy, and when you're ready, you can unpause it. We'll carry it out. All right, so common theme. Maybe look at triangle ABE. We need this height. We only have an angle, not enough information. Can we find a shared side that might help us? Does me saying that out loud help you guys with the strategy? Mackenzie? Yeah. BE is a shared side in those two triangles. So maybe I'll just put a little 1 here. If we find side BE, well, that will allow us, put a 1 here. That will give us the bottom side of that middle triangle. And then we will have enough information to use SOHCAHTOA to find that height. We actually don't need the third triangle. This is just 2 steps. And you guys could have done this question in grade 10. It's just breaking down a 3D diagram is what's kind of expected at the 3U level. So step 1, let's find side BE. Now, I use the sine law in the warm-up just to show you guys you can choose any tool that'll fit the job. But normally I would reach to SOHCAHTOA. I think it's just the most efficient way to do it. So 1,200 is the hypotenuse. The side BE is the opposite side. So we're going to use the sine ratio. Sine of 50 equals BE over 1,200. We got this, not so bad. So BE would just be 1,200 times sine 50, whatever that is. Call that 919. Let's just go 919 meters. Do you guys get that as well? Nod and smile. All right. I think I might tuck that in on this diagram here, 919 meters. And yeah, SOHCAHTOA one more time. Can you guys find the height? And we've got it. So you can call it AB, you can call it H. but we're using the tangent ratio here because it's the opposite side. So tan of 12 equals AB, or H, whatever you prefer, over 919. That seems pretty tall, but I'm not an engineer who makes these towers. Did you guys get 195 as well? Okay. I'm sure there's towers that are that tall in real life. 195 meters. Tower is this tall. All right, it's another 3D trig problem. Strategy for you guys: break it down into simple triangles, draw them out, and then you might be able to determine a strategy here. I think this one was approachable. IMO. That means in my opinion. Anything you guys want to chat about? Note we had 3 triangles. Didn't have to do 3 steps though in this particular problem. All right. Now the diagram was given to you in that one. In the next one, the idea here is for you guys to have to visualize a little bit. So what we have here is a bird's eye view of the infield on a baseball diamond. You guys are familiar with baseball? A little bit? Okay. So the batter at home plate in this question hits a fly ball straight up in the air. So if you can imagine the person at home plate, the ball is like going to come out of your screen 15 meters into the air. The pitcher is going to watch it as it goes up, and the idea here is we're going to find what is the angle of elevation from the pitcher to the ball. That maximum, when it's at 15 meters, what angle is the pitcher looking up at? But notice, no triangles drawn here for you guys. So I'm going to give you guys a bit of a tip to maybe draw out some triangles. I'll wait a second, and then I'll come along for the ride. We're going to need a triangle formed by the pitcher. I'm going to put a dot here and label that with a P. The home plate, I'll label that with an H. And the ball itself, which is above home plate. So that's going to be kind of like a right angle triangle like so. Here's the pitcher. Maybe draw, there's my pitcher. There's home plate. Do I have blue? No, I was going to draw a blue person for an umpire, but I'll just leave it as it is. And I'll maybe draw a little ball up there too. How's that for a ball? That's a nice circle. All right. So the ball is hit straight up in the air, 15 meters, and our goal in this question is to find this angle of elevation. Obviously, we don't have enough information in that triangle to find that. So here's where I'll let you guys think for a second. Is there another triangle that we could draw that maybe shares a side with that one that we could use, like in the previous question, to do like an initial step that'll help us find that angle of elevation? So I'll wait a sec while you guys have a think on that. There is multiple options here. You can see there is this piece of information we haven't used. Bases are 27.4 meters apart. And the base paths do form a square. Jillian, you have an idea? I liked how you said or there. I was ready to do third base home plate pitcher, but yours will work just fine. The distance from home to first base, we're told, is 27.4 meters. I right now though only have a side. Jillian? Did you reason out an angle in that triangle though?
No.
Okay. Graham? It'd be 45 exactly because we're kind of cutting that square in half. So 45, 45, 45. And look, it's a couple right triangles. By drawing this out, we can see that PH is a shared side. you have enough information in the right-hand triangle to find pH. So now it's like a grade 10 problem. It's find a side using SOHCAHTOA, and it's finding an angle using SOHCAHTOA. But it's the setting up the 3D problem that is like the 3U aspect of this. The math is grade 10 level. So maybe over here, I'll just say 1, find side pH, 2, find angle P. You guys got options. You have all the angles here, but if I dial in just on this one, we're going to use the cosine of 45 degrees equals pH over 27.4. You could have done sine as well, would give the same result. But as I said, we're just in SOHCAHTOA mode now, just like back in grade 10. 27.4 cos 45. pH equals about 19.4. You guys get 19.4 meters? All right, let's wrap this up then. I think I can just fit this over here for step 2. So pH, 19.4. So the tan of P equals opposite 15 over adjacent 19.4. And we'll solve for P. I'm going to tell my calculator to do that all at once, do the division, and then do inverse tan. And I got 37.7 degrees. So we're done. That pitcher has to crank his neck up about 37.7 degrees. All right, so I mean, hopefully I've kind of got the message across. The math is just grade 10 math for you guys. It's SOHCAHTOA, maybe sine law, cosine law, but the expectation in the 3U course, can you parse the information from a diagram, or can you create your own from a 3D problem? That would be the challenging thing. And it's I can only do so many examples with you guys. It's better if you just actually wrestle through a few on your own with your C partners. So that's what I'm going to have you guys do. I'm going to end the video here, and I'm going to get